Hello, welcome to PhyzQuest. So this is the solution video for GATE 2020 Physics. Question number 7. The question is, the total angular momentum J of the ground state of the oxygen 17 nucleus is, we need to calculate. 4 options are given and we need to calculate the correct option. So let's get started. So this question comes from the section Nuclear and Particle Physics, and the concept involved here is nuclear shell model. So in this question we need to calculate the total angular momentum of the ground state of oxygen 17 nucleus. To calculate the total angular momentum of the nucleus, we need to use the nuclear shell model. Like atomic shell model, nuclear shell model is very much similar to that. So in atomic shell model, it describes the arrangement of electrons in an atom into atomic energy levels. So like that, nuclear shell model describes the same for the protons and neutrons in nuclear energy level or nuclear energy shells. So to determine the total angular momentum of any nuclei, we have to follow two rules. There are two rules. First rule is filled shells have zero total angular momentum, which means even number of nucleons will have zero total angular momentum. Now second rule is nucleons in the unfilled shell will contribute towards the total angular momentum. So that means when there are odd number of nucleons, that will decide the total angular momentum. Now here we have the nucleus which is given is oxygen 17, that is in the ground state. So we have here number of protons is 8, which is even. Number of neutrons is 17 minus 8, that is 9, which is odd. So that means here, as following the above two rules, here the presence of odd number of neutrons will contribute towards the total angular momentum. Now in how this nuclear shell model will help here? See, nuclear shell model, the nucleons will go to different energy level following a certain sequence. So the energy shell, the nuclear energy shell follow this sequence, that is 1s half, 1p 3 by 2, 1p half, 1d 5 by 2, and so on. There is a list of the energy shells. Now here in 1s half, it can occupy 2 nucleons. 1p 3 by 2 can maximum occupy 4 nucleon. Similarly, 1p half also can occupy 2 nucleon, and 1d 5 by 2 can occupy 6 nucleons, and so on. So here we have, let's check that. We have got the nucleons, that is number of protons and number of neutrons. So we will check their arrangement in different energy shells, and accordingly we will decide what will be the total angular momentum. So we have 8 number of protons. So here first 2 protons will go to 1s half, then 1p 3 by 2 will occupy the 4 proton. Now 2 plus 4 is 6. We have 8 protons, so remaining 2 protons will go to the shell, that is 1p half. So here the final shell is a filled shell. So here the total angular momentum will be 0. So protons will not contribute towards the total angular momentum. Now let's check with the neutron. So we have 9 neutrons. So first 2 neutrons will go to 1s half, then next 4 neutron will go to 1p 3 by 2, then after that 1p half will occupy then 2 neutron. So 2 plus 4 plus 2 is 8. We have 9 neutrons. So the last neutron goes to the state 1d 5 by 2. So here the last shell is unfilled. So therefore the associated angular momentum with this shell is 5 by 2, and so the total angular momentum of the nucleus will be decided by the neutron that goes to this last shell which is unfilled here. So the angular momentum associated with this shell will be the total angular momentum of the oxygen nucleus. So the total angular momentum of oxygen 17 nucleus is 5/2. Now let's check the option. So here, if you can see here, option D is matching with our result. So the correct answer is option D.